in this next video, I'm going to make a project where I take one voxel and duplicate it to actually draw many voxels called like a voxel chunk. All right, so let's start a new project and I'll just call this Vox206 and I'll say create a 3D project. Okay, to my project, I'm going to add a sprite here that's going to be used for my texture map, and I'll make a material out of that. Material, I'll call it terrain map. And the material, as you notice, has these tiles of different pictures, and that's how I could make from one material onto this one voxel mesh. All the different little voxels have different materials because they're actually in one material. I just picked different UV coordinates. So now here's my terrain map. Let me drag and drop that there. And that's how it looks like as a cube. There's different shapes there. So that's one. Then the next thing I need are some scripts. So I have my Voxel class. This is not going to be a model behavior. This is actually going to be a class that I made to hold my voxel data. Okay. And just running through it real quick, I have a helper here with a bunch of enums, the corners, the sides, which texture from the material, and then which voxel type. So depending on the voxel type, I kind of put different textures on the sides of the voxel. Then there's this enum side bit. This is basically binary. So a value of 1 would be like 1, 1, 2, 3, 4, 5, 6, 7, 8. And a value of 2 would be actually 0, 1, 1, 2, 3, 4, 5, 6, 7, and so on for each of these values. And what happens is if I set an integer equal to back plus right, then the first bit and the second bit will be set, and I could test for that. So one integer, I could test for a combination of any of these values here. Then I have since there's a lot of variables for my mesh data, like where do I start my mesh data indices in the chunk for this voxel. This is the voxel class. I have the start. Then I have the offset position of this voxel class object in the chunk, because every voxel can't be right there at the beginning of the chunk. Some of them are going to be offset in the X, Y, and Z direction. And this is a thing I kind of have calculated so I don't draw sides that are not visible. And then here within the mesh data, I have the 3 actual arrays, which I'm not going to use in my voxel class, but the chunk class is going to use it. And then to figure out texturing, I have a little subclass in my helpers here where the layout is of the texture we're using is a 4x4. As you can see here, it's 4x4. And the pixel size of each tile in the texture is 128 pixels by 128, which means the width of the entire material texture is 4 times 128 or 512, the width and height. And the coordinate, the low and high, that's used in some calculations for the texture map. All right, so now those were my helper variables. Now I have the class. This is going to be similar to the other video I just did on the voxel itself, except some things are changed a little bit. Here, when the voxel class is instantiated, it kind of gets the data for this voxel, sets to the chunk array. This gives me the corners. This gives me the sides, the vertices side points. This gives me the UV points for a piece in the texture. And then over here, this sets a voxel type, which means like what textures do I map on each side of the voxel. So the appearance of the voxel. Then over here, I set the triangles by side, and I can pass a value of either setting the triangle on or off. If the triangle's on, then all the points will equal 0, which means they don't show, or it'll equal indices to the vertices, which means it'll show, and that's the 6 sides. And then this is where I use that enum bit that I showed you with the binary comparison. So you could pass in a code. A code is an integer where I just keep adding all the sides that I want, all the enum bit sides. And then I could test here against the code to see if that particular bit is set for back. And I can set the back, the front, the right side. It's just something cool. And over here, this function is public. It's going to be exposed from the Voxel class, and somebody could call this and say, turn on this voxel. And when I turn it on, it's like, which voxel do you want it to be? A grass, a dirt, and then it calls all the sides and turns on the voxel, and then it sets the voxel type for the appearance of the voxel. And if another public function over here is just called turn off, it just turns off all the triangle sides so you don't see the voxel anymore. So that's the voxel script, and that is not going to be added directly to a game object. That's just a class that we need. Then we're going to have the chunk script over here. This is going to be added to our game object here in the scene. So I'm going to create an empty game object and call it chunk. And the chunk script is something that I'm going to add to that empty game object. Boop. And it automatically added the components. Good, because we're going to be generating a mesh with the chunk thing. This says how many voxels we're going to make the chunk in size, 10 by 10 by 10. Over here is a nifty little thing, so we can set the voxel sizes, and this is the side optimize checkbox to see whether my script is going to actually draw the sides you can't see or not draw them. All right. So that's the chunk script. It needs something though. It needs over here the material which we just made. So let me drag and drop that there. It's not asking for anything else here. So that's good. Let's save that. And let's run this and see what happens off the back. Let me just rotate my scene view so that Z is pointing forward. And let me adjust the camera that way as well. Control-Shift-F. All right, so if I press play with the chunk script, which I haven't showed you yet, let's see if I get a chunk of voxels. I do. I get a chunk of voxels, 10 by 10 by 10. I wonder if I can make it bigger. Let's see if I could go 20 by 10 by 20. And I press play. And stuff started happening. It looks like it didn't completely draw itself properly. Now, at first I was like, oh no, I have a problem in my code. Something's wrong. But it's actually not that. It's actually that for every mesh that Unity has, there can only be so many vertices in the mesh. And when I told it to make 20 by 20 by 10 voxels, that exceeded the vertex count. So that's kind of like, well, we'll have multiple chunks to make an entire world. But right here, we're just going to make one chunk. And I know that 20 by 20 is too big. So here I will just go 10 by, maybe I can make it deeper though, 18 by 20. Maybe I could just get it deep and still have enough points. Let's see. No, I can't do that. Can I do 18? I think it's like 64K of the, oh wait, I still have this as a 20. That's why. 10, 20, maybe now. Run. All right, there. I got a pretty deep chunk, but there you go. That's a chunk. Now, I wanted my chunk deep because in the next video, I'm going to like put a bunch of chunks together and I want the hills and the mountains to be big, you know? Oh, okay, so let me just explain something about the voxel size. Right now, every voxel, the size is a unit of 1. So this voxel size is actually half of what the voxel is going to be. But I have this voxel size thing here so you can see what happens when there's multiple voxels, that between the voxels, let me turn off side optimize. If I were to render every single side, and I get close over here and zoom in, you could see that every single side is drawn. I made the voxels a little bit smaller so you could see the space between the voxels. Now, if every single side is drawn of all these voxels, it's going to give the computer a lot more to work on. And when we're regularly playing the game, you're not even going to see those sides on the inside. So that's why in the chunk script, I have this thing called side optimize. It checks for voxels that are next to each other that are on and doesn't draw the side between them. So here, if I press play with the side optimize on, you can see in the inside, it's all clear. See all that clear stuff? You can see right through. And the only sides that it draws are the ones on the outside. And that saves the computer some time and keeps things a little bit faster. All right, and now I could put the voxel size back up to 5 and you wouldn't even know that the inside wasn't drawn of the chunk. See? So that's why I have the side optimize in my chunk script. So let me go in the chunk script and show you that. So the chunk script, it has a job to actually give the data to the mesh because it's the game object with the mesh on it right here. So the chunk script's going to have to get all the data for all those voxels. And that's where I use the Voxel class. So let's see what we have here. This is when we drop the script to make sure that we have the things. I'm not using this anymore, the Unity events. This gives us the 3 components on the game object to make sure that they're there. All right. Then we have some helpers for myself here, and this is some helpers that it's going to fire off an event, okay, which I'm not going to go into that right now, but basically that's so another script, like the player that's going to walk around the voxels, could know once the chunk was rendered, because you saw when I press play, it takes a moment to render the chunk. See, I press play, it's taking a moment, and then the chunk comes on. So when the chunk comes on, I'm actually going to fire off an event. So a delegate is a pointer to a function, and then here I make a static event for that on chunk rendered. So the static event is going to be what I can call in my script over here. I could like actually invoke the on chunk rendered, and it will fire off an event that tells all the other scripts, hey, I finished rendering. What do you know? I just told you about it. Okay, now next I have the size of my chunk, 10 by 10 by 10. The pointer, this is going to be like for holding all the mesh data, and it's kind of complicated, but this mesh data is defined in the Voxel class. So let me just control click. So it has the start of the vertices, the offset of the voxel. This is the start of the index for the start point in all the arrays for this voxels data. This is the position of the voxel in the voxel chunk. So you see the one chunk here has all these different voxels. They're not all in the same place, they're all offsets. So the offset there tells me the position of this particular voxel, if the sides are always on. And then here's the arrays for the vertices, usually in triangles. That's what this is, the data object. This is the voxel size, and this range thing is what keeps this little scrolling bar here for the values to go from a minimum of 0.25 to a maximum of 5. See, 0.25 to 5. Side optimize, I think that's this. Yep, that checkbox. And okay, here we have our array of voxel objects. Now, this is where the voxel class gets used. This is a voxel class. It's not derived off of model behavior. So it's just a regular C# class. And I have an array of them, a 3-dimensional array to represent each voxel in the chunk. You get a pointer to the mesh, and this little variable says if the chunk was rendered or not. It's going to be set to true. All right, so in the start of my chunk thing, and I think it's going to be faster if I demonstrate how this works. I'm going to attach this to Unity, and we're going to debug step through it. And then when no, a crash. I'm just restarting the project. Okay, it looks like some of the stuff I did wasn't saved. So let me once again, wait, maybe it is. Here it is, sample scene. There we go, there's a chunk. And I was looking at the script. Reopen that. Why'd it crash? I don't exactly know. But I do know I'm dealing with memory here, creating a mesh and, allocating for it and stuff. So I could have made some mistake somewhere. I don't know. All right, so I attached to Unity here in Visual Studio, and now I'm going to run Unity, and we should be able to step through and debug to see what happens in the chunk script. So here we are, it's flashing, and we're here on the start. And we have two functions, init chunk and render chunk. So first is init chunk. So, its job is going to be get all the data set to define the mesh. So do we have our voxels array set? No, we don't. It equals null. So it's going to not do anything. Oh no, voxels doesn't equal null. Okay, so we're going to come in. Here we go. Number of vertices for 10 by 10 by 10. The number of vertices we need in our array is 24,000. Therefore, that's how many we need in the UV. And then for number of triangles, we'll need 3,600. And now this data object is holding all our stuff that we're going to give to the mesh. So we allocate the vertices array, the UV array, and the triangles array. We allocate the size of them in memory. Now we allocate also the size of our voxel class objects. Each one is a voxel in our chunk. And at first it is null, and now it is not null. Ba-doom, ba-doom, ba-doom. Okay, so we're going to go through each voxel in our chunk. We're going to keep track of where in the vertices, UV, and triangles arrays the voxel should set its data. So the first voxel is going to be 0, 0, 0. And we go through, it's a triple loop. Okay, and the X, Y, and the Z axis, we're going to have voxels. So first thing we do is we make a new mesh data object that's holding our data in the script for the mesh. Okay, come on, little thing. See? So we're going to set the vertices, the start UV, and the start triangles for this right now is set to 0, 0, 0. So the offset of this voxel is going to be 0, 0, 0. It's the first voxel in the first position. And we're going to give this little data object that we're making a reference to our array in the chunk. Bing, bang, boom. And then over here, we're going to actually, this is not going to be a script. This is a voxel object. Sorry, let me stop. A little miswording, and that could confuse people. So this is a new voxel object. So let us call this instead a more meaningful name, voxel object. Okay. And I'll just put a breakpoint here. No. And then I'll say attach, and we'll start it over again and continue. Play. And here we are. Let's go to our second breakpoint. Here we go. This is where we left off. I just renamed this to make it make more sense. This is going to be a voxel object. This is the voxel class, right? So we get a voxel object now, and oh, this actually had a constructor that initialized it with the pointer to the data, the type of voxel I want it to be grass, and the size of it 0.05. And inside the constructor, the voxel actually set all its values, and I didn't step into that, sorry. So now I have a voxel with its data, and I set that to my voxel array at position 0, 0, 0. And now I have to get ready for the next voxel. It's going to set its data at our chunks, our meshes data indices starting at 24, 24, and 36. So if I just kind of quickly come again, and this time I again stepped over the constructor. What is wrong with me? All right, I'm going to put a breakpoint this time and press continue. Here I am. Let's see what happens in the constructor for the voxel that we pass these three things. I'm going to step in, and the voxel class kind of goes through its initialization. Here's the constructor. We set inside the voxel class, we have our own variables, so we kind of set them. Okay, and then we define the vertices for the side. Now the vertices for the side is going to actually use the data object to set values on there. So the first side we're checking is the back side. So it's going to come in here. The offset is the start vertices, which is 48. Okay, it's 48 on this voxel. And then the side, which is the back side, times 4. So what is the actual index we start setting? 48. All right, so here in the back, the vertice at 48 is E, 49 is F, A, and B. Okay, and that did that. Then we do all the vertices, and then we kind of do the same thing through each of these functions that we made to set the vertices, to set the UVs, and then to set the triangle polygons. So that's the complexity that is in the constructor. And we go through this loop and actually do every single voxel in our chunk. We're turning every voxel on and making every voxel the same thing, graphs. So let's just let it run out. And we come back to here where the init is. The next thing after we have all this data set in our chunk script, we have to actually give it to the mesh. So we're going to go to render chunk. First thing we'll make sure is we have a pointer to the component's mesh object. So let's see what get mesh does. Yeah, our pointer's not set for the mesh object. So mesh equals null. So we're going to say mesh equals new mesh. We're going to allocate a new mesh. We're just going to give it a name so it shows in the inspector window as chunk. And then we set the mesh filter mesh equal to this mesh. And the mesh collider also needs a reference to the mesh. Okay, so now our mesh is created, but there's no data on it. I'm going to set the game object to inactive so it's not drawing on the screen while we do this update. So set active to false. And here I'm going to check if the optimization is on for the sides so it doesn't draw the hidden sides. And the check is true. So let's see what side off optimization does. Its basic job is going to be to go through all the voxels, X, Y, and Z. And for each voxel, it's going to check to see if there's a neighbor on that side. Okay. So this is the logic. And then we're going to set the triangle side for this particular voxel. We see if that current side is on. The current neighbor on that side is on. And if it is, then, yep, so we have neighbors. How many neighbors do we have on a voxel? We have 6, since there's 6 sides. The front, the back, the left, the right, the up, the down. So we're going to see if which neighbor side are we checking here? We're checking the neighbor on the back side of our voxel, and we're going to see first if there is in the chunk a voxel behind this current voxel, and we're going to see if it's on. Or if it's not, then 0 will be neighbor on as 0. So is there a voxel behind me? No, there isn't on this particular voxel as it's looping through. It's going to do that for every voxel side of this voxel, and then it'll do it for every voxel when it goes through these loops. And then when it gets here, let's say run the cursor to get to this point. When it gets here, side edges always off. Oh, this was, what is this doing? This is side edges always off. This was me trying to figure out that the voxel's on the absolute outside edge, but this is not working. So I'm just going to step out of that. That's not working yet. Okay, and that is going to go through for all the optimization. All right, and now we're going to set the data to our mesh. Remember, we have to set the data to the mesh. So this is the data in our chunk script, and we're going to actually put it on the mesh. So we got the vertices, the UV, and the triangles. Now, thankfully, Unity provides a recalculate bounds to recalculate the size of the mesh now that it has vertices, and recalculate normals so the light knows how to shine on it. And now we could turn the game object back on. Blink. Okay. Now here, this is the first time we're calling render chunk, so render chunk is still false. But now we're going to set it to true, and we're going to fire off an event. So this onChunk rendered was our static event from up here in our helper, onChunk rendered. Now, it's null if nobody's listening for the event. If there is no other script that called add listener function to listen to this onChunk rendered event, then this is null. And if it's null, it won't invoke the event. Otherwise, it will invoke the event and it will fire off into the system of all the scripts so it could read it. But that doesn't happen here. And what happened? So there we go. In our start, we initted and rendered the chunk. And then we see the chunk in the game. So what is next? Next is we want to be able to walk on this chunk with a player and click things on and off. So let me press stop and let me add a player. Game object, let's add a capsule shape as a player. Okay. player. And the player, what do we gotta do to you? We need a script for you. So we got this script here. First person controller, so we can move it around with the mouse and the keyboard. And we'll drag and drop the first person controller script onto the player. All right, so we can move it around. Oh, it added a rigid body. That's good. That's good. So this player shape is like a capsule, and I have a rigid body, which means that it'll act like it has physics. I don't want the little pill to fall over, so I'm going to freeze rotation on the X and the Z. And also, if this little player pill guy hits things, I don't want to start spinning out of control, so I'm going to put some drag on the spin so he doesn't spin so easy. Let's see what the script needs right here. First person controller script. It has a move speed, a turn speed, a jump force. Oh, but I need a camera. Okay. I need a camera, and I know why I need a camera. It's going to be because as I'm moving around, I'm going to click with the mouse to add and remove voxels, all right? So press save and play. And my guy kind of drops right through. Oh, I wasn't expecting that, but I think that happened because I have to make sure that my player is high enough up that he falls onto my chunk instead of being inside the chunk. So I picked him up a little higher. Let's see if that works. Oh yeah, I picked him up real high. And he's coming down and whoa! He just missed the freaking chunk. All right, let's move him over a little bit too. Let's move him over a little and let's see what happens now. Is he gonna land on it? I think he's missing it. All right, we're playing games too much here. Let's see. The chunk's position is at 0, 0, 0. My player's position is like it's off. It's not at 0, 0, 0. So first let me make it 0, 0, 0. Then from there, I guess I could just move him over and in a little bit to be over the chunk. So now let's see if that works. Oh, I forgot to move him up. Sorry, let's do that one more time. All right, so let me stop and think. The chunk is at position, let's see, 0, 0, 0 with a size of 10, 10, 10. Okay, good. So if my player, if I move him over from 0, 0, 0, 2, and 2, that's within 10. And then if I pick him up by 30, that's above 10. So that should work. Let me press play. And my player falls and lands on the chunk. All right, we can see what's going on here. And if I click, I want to see if I could add and remove voxels. But I'm clicking here to remove a voxel with my mouse. It's the right click, and I have a little error message at the bottom of my status bar there. It says chunk is not defined. It says it right here, chunk is not defined. So, aha! I have to add a tag to my chunk. All right, that way I know I'm clicking on chunk. So let's add tag. Let's call it chunk. That's what it wants. And then let's set chunk to use that chunk tag. Bam. And you know what? The chunk isn't going to move. Let's set it to static. That way we could like save more processing power in Unity. And now my player falls down onto this. And if I click, I could remove voxels and I could add voxels. Yay, that's good. So I could let's explain the remove and the add. Let's see that. We will go from the player script, from the first person controller script. Yes, right here. First person controller. I just here to determine the mouse button click, left, right, middle, 0, 1, or 2. This is the speed I could move and turn, the camera, and the rigid body, so I can get a pointer so I could jump. So here in the start, I get a pointer rigid body, and if somebody defined the camera on my player over here, then I will set the bounds B. I will get the bounds of my player, the little capsule, and I'll set the camera to be positioned in the middle of my capsule, and then I will set the camera to be a child of my capsule, my player. All right, so I basically take the camera and make it a child of player in these 3 lines of script. And then I'm going to hide the mouse because we're using the mouse to move around in first person. On the update, I see if somebody pressed the escape button and then I unhide the mouse. Or I look for the input axis of vertical and horizontal, which could be WASD. It could be the arrow keys. It may be a joystick. This is in the input settings that if I read vertical and horizontal, whatever that's set to, I'm going to read those values. And then I will move forward and left and right, but not turning. I'll just move forward and left and right. Now, for turning around, I'm going to read the mouse axis. So if I move the mouse on the x-axis left and right, I'll turn left and right. And if I move the mouse up and down on the y-axis, then I'll actually rotate the camera, which is a child. I'll rotate the camera up and down. And I do it on two separate object axes because if we're to do it on the same axes, the local rotations, they kind of get messed up. So just keep it simple. I spin myself around looking left and right, and the camera, I spin it up and down. Now here's a jump. If I press the space bar, I just add some force to jump. I don't need this anymore. Oops, the code's running. Let me just stop that. Stop that code. Say it, stop it. You're not running now. And delete you. What? The code is not running. Anyway, then over here, okay, here we go. This is where I do it. If I click the left mouse, I add a voxel. If I click the right mouse, I remove a voxel. It's going to take a look at where the mouse is and add a voxel or remove a voxel where I'm pointing to on the mesh. So here I want to like put some breakpoints here. And what's going to happen if you think you're running and I tell you to run? I'm going to attach to Unity, and then here I'm going to run in Unity again. So we can step into the add and remove voxel, see how that works. Because it's complicated. Because basically this whole chunk I'm standing on is one mesh. It's one mesh. So how do I know which vertices to remove in this mesh? All right, I'm going to click here, click, and I click to remove, right? I click the right mouse button, and it's going to call the remove voxel function in my first person controller. So let's go and see what that is right here. So what I'm going to do is I'm going to create an array that goes from the camera to where the mouse is. And then I'm going to actually use physics to cast the ray into the scene and see if it hits anything. And I'm only going to cast at a distance of 3 units. So I have to be close to what I'm clicking. And I did hit something, see, because I came in the inside of the if. So what I hit, was it a chunk tag? And it is. Oh, good. Now we're getting somewhere. So the thing that I hit, I get its game object, and I get the script of the thing that I hit. I get the chunk script. Okay, and now with the chunk script, I could call the remove voxel function and pass it the hit. So I go, and now I'm in the chunk script, remove voxel, which takes raycast hit. So I'm going to use the normal and the hit point to determine which voxel I'm in. So the normal would be a point that kind of comes off of the surface of the face that I hit, the polygon, comes off in a perpendicular angle, straight off there. And the size of the normal is always a size of 1, pointing away, pointing toward me from what I hit, okay? But since I want to remove a voxel that I clicked on the face of, I want to go the opposite direction of the normal. So I multiply by minus. And I got to make sure I'm inside the voxel when I go in the other direction. So as long as I go a little bit, like 0.1, I'll be inside. So that'll be a point inside the voxel. And that point equals 2.3, 9.4, 1.9. Okay, it's not whole numbers. And then this quantized point is going to round it off to whole numbers, basically to the center of the voxel. All my voxels in the chunk are located at whole number positions. Okay, so here that point that has, those decimals, this function is using math from C#. It's using the math class from C# to round. And the reason I'm using the math class to round instead of math F from Unity is because I have to use the midpoint rounding. All right, bam, bam, bam. And now X is 2, 9, and 2. Okay. So that should be a voxel at 2, 9, 2. I'm going to return that point back to the caller, 2, 9, 2. Now the only thing I have to consider is if my chunk is not at 0, 0, 0. So I'll take my 2, 9, 2 and see the difference of the position of the chunk. which my chunk is at 0, 0, 0, so that still works. And now I'm going to see which voxel it is, and I turn it off. So I'll get the voxel at position 292 and say turn off. Remember, I have an array of voxel objects from my voxel class. And here's the turn off function, and basically it takes every side and turns it off. Okay? So that voxel will disappear. And then I have to just render the chunk over again with the voxel gone. So I'm just going to say continue. And there it is, the voxel's gone. If I want to put a voxel back, I'll aim there and I'll do a left click. Yeah, okay, so now I'm in the add voxel. And add voxel is going to do the opposite from remove voxel. Let's step in. So I'm going to cast array to see where I hit on the mesh. All right, and if I did hit a chunk, I did. And I get the script and I call add voxel on the chunk script. So here's add voxel. So on remove voxel, I multiplied by a minus. Now on the add voxel, I'm going to multiply by a plus value to move into the voxel that's the neighbor to the side that I hit. So I'm going to move back from the point that I hit and get that point. Okay, so what is it? The point that I hit was that, and then back from that point is this. So now I'm inside the space of the neighboring voxel that's not there yet. And now I'm going to account for the position of the chunk if it's not at 0, 0, 0. All right, now I have to do the rounding so I could get the exact voxel position because there are no voxels in decimal positions. Bing, bang, boom. So now P is whole numbers 292. That's the voxel I took away. Now I'm going to put it back. So voxel at 292, I'm going to turn it on. And what kind of voxel am I going to put there? I'm going to put a water voxel. So that turns on, and we should see a water voxel. All right, so that's how that works. And that's the end of this tutorial. What I want you to do, though, is go to omarvision.com/tutorials and search for voxels and meshes, and you're going to see this video. And under the video, you'll see the links there for the scripts and even the Unity package. All right, so you don't have to type everything in. You could just use that. Hey, thanks a lot. See you.